Hello everyone, welcome to the research classroom. As you know, I have started solving minor question paper, each and every question in detail. So we have successfully completed our group A portion and have solved each and every question on group A. And you know, we have also solved objective portion from group B. So in today's class, I shall solve some important questions from previous year question paper 4A to E. There are 4 important questions in this section. Each question carries 5 marks. প্রত্যেক কটা কোশ্চেনে 5 marks আছে. So just go through this video and you shall get an idea about the question paper, its difficulty level and everything. Okay. So question number 4A to E is our target in this class. So let's start with question number 4A. Question number 4A is find the GCD of 315 and 4235. At first, you need to find out GCD. GCD of what? GCD of 315 and 4235. And after that, you have to find the integers S and T such that this GCD become 315S plus 4235 into T. Okay. So I have solved this type of question in objective part. Okay, at first go to the objective part. Actually, there is a result. If GCD of A and B equal to D, suppose GCD of A and B equal to some D, in that case, how we can write this? Answer is we can write D as A into some integer plus B into another integer. This is our important result. This is an important result from GCD. If GCD is D, then D can be written as B is equal to A into some integer plus B into another integer. That is entire integers. So at first, our target is to find GCD. Now, how to find GCD? We have done this type of question in our objective part. So for GCD, the rule is at first express 4235 as a multiple of 315. Okay. These are very basic questions. Okay. So you can usually solve this type of question. We have to first express 4235 as a multiple of 315. How you can do that? We are dividing 4235 by 315. If we divide 4235 by 315, see that 1, 315, 8, 0, then 1, 108, and then 5, then 3, 5 to the 15, 6, and 965. Okay, so 965 and giving you, sorry, actually 13. Sorry, this will be 4. Sorry, this will be 4. Yes. So 0, 4 is of 4, 1. So 140. So that means we can write 4235 like 4235 equal to this into this plus this. Okay. This is basic division rule. We can write 4235 like this. 13 into this plus 140 as we have written here. Then at the next step, we have to express 315 as a multiple of 140. 315 as a multiple of 140. We have done so many problems like this in our class. Okay. So if you want to get more solution like this, so you can join the class. Okay, because these are the common questions that we have discussed in our class. Okay, so if you want to join, then you can use the phone number given in description box. So how you can write 315 as a multiple of 140? Say that 140 equal to 280, then 35. So 315 can be written as 2 into 140 plus of 35 like this. Okay, like this. And finally what? And finally write 140 as a multiple of 35. So 140 is equal to like this, 140 as a multiple of 35. So 3, so 105, so 35. That means 140 equal to 3 into 35 plus 35. As written here, And finally, express 35 as a multiple of 35. 35 as a multiple of 35, that can be written as 35 equal to 1 into 35 plus 0. Now my target is to get this 0. Whenever we shall get this 0, our problem is over. Okay? So continue this process until you get 0. And finally, you can see that this 35 is our GCD. So our GCD becomes 35, which is our D in this theorem. In this theorem, there is my D. Okay? So first part is done. GCD becomes 35. Again, repeat, we have done so many questions. Okay, so it's a basic question. You can find this solution in the. You can find this question in any standard book. Now, what is my next part? My next part is to express this GCD in this form. How we can do this? See that this is my GCD 35. Now this is totally a back calculation. Totally a back calculation. See that from this we can write 35 as 140 minus 3 into 35, right? See that 35 can be written as 140 minus 3 into 35. Okay. Done now? Then what? So we have written this 35 like this. Or you can directly use this step. You can directly use this step, this 35 from 30. See that this is also 35. So write down 35 as 315 minus 2 into 140. See that 35 equals 315 minus 2 into 140. Now keeping this 315 fixed, substitute this 140. We can substitute 140 from this step. See that from this step we can write 140 as 48235 minus 13 into 315. Like this, we can write like this, okay? Then this is equal to 315 minus 2 into 4235 minus plus 13 to the 26 into 315. Okay, done. So we write 35 like this. And finally, I'm writing here 35 equal to my left hand side is 35. Okay, see that here my coefficient of 315. Here my coefficient of 315 is 1. And here my coefficient of 315 is 26. So 1 plus 26. And this portion given as it is. This gives you 35 equal to 315 into 27 plus 4235 into 2. Say that. So this 35, we have written this 35. This 35 is what? This 35 is GCD between these two. So what GCD between these two is written as 315 into S. See that there is my S plus 4235 into T. So there is my T. So my S become 27, my T become 2. Okay. So these are my values of S and T. So there is the question. So it's a standard result. And using this standard result, I proceed like this. At first we find GCD. My 35 is GCD. And then by back calculation, we replace 35. Then we replace 140. Then after a simple calculation, we have done this. So these are my values of S and T. Okay. So if you like this solution, so please subscribe to my channel and inform your friends who also want to get solution of these questions. Okay. Okay. So my next question is find the remainder when 1 factorial plus 2 factorial plus 100 factorial. See that the question is you have to find out the remainder. Remainder when this 1 factorial plus 2 factorial plus 100 factorial is divided by 40. Okay. So basically the thing is 1 factorial plus 2 factorial dot 100 factorial. You have to divide this by 40. You have to find out the remainder. There is the question, right? Now how we can solve this question? See that. First of all, see that 1 factorial is equal to 1. which is not divisible by 40, right? Next, 2 factorial equal to 2, which is not divisible by 40. 3 factorial is equal to 6, not divisible by 40. 4 factorial is 25, not divisible by 40. 5 factorial, it is 120. Yes. So now 120, see that this 120 is divisible by 40. 120 is divisible by 40. Okay, so 5 factorial is divisible by 40. 40, yes. So first factorial, which is divisible by 40, is 5 factorial. Okay. Now, if 5 factorial is divisible by 40, then 6 factorial can be written as 6 into 5 factorial. And since 5 factorial is divisible by 40, 6 into 5 factorial is also divisible by 40. So see that if 5 factorial is divisible by 40, so 6 factorial is also divisible by 40. Similarly, 7 factorial, it is 7 into 6 into 5 factorial. It is also divisible by 40 because 5 factorial is divisible by 40. So like this, all the numbers 8 factorial, 9 factorial, dot, 100 factorial, all are divisible by 40. All are divisible by 40, right? So my remainder, so from this portion, we have no remainder. Why no remainder? Because all these numbers are divisible by 40. So divisible means no remainder. So from this portion, we have no remainder. Okay. So 8 factorial, 9 factorial, 100 factorial. From all these numbers, we are getting no remainder. So my remainder comes only from this portion. Okay. So remainder kotha theke asche? Remainder asche only a portion ta theke. Okay. So my remainder comes from this portion. Okay. So see that my remainder comes only from this portion. Why? Because after 4 factorial, like 5 factorial, 6 factorial, 7 factorial, all of them are divisible by 40. Means no remainder. So my remainder comes only from this portion. Because this portion is not divisible by 40. So how you can find the remainder? 1 factorial is 1, 2 factorial is 2, it is 6 plus 40. Sorry, 24. 4 factorial means 24 by 40. Which is equal to 33 by 40. Okay, that means my question is, what is the remainder when 33 is divided by 40? Because from 5 factorial, we have no remainder. We have remainder up to 4 factorial. So my question becomes, what is the remainder when 33 is divided by 40? Answer is, my remainder is 33. Why? Because 33 is less than 40. 33 is less than 40. So if we divide 33 by 40, my remainder will be 33. Okay, so my answer of this question is 33. Okay. Please find f of g and g of f. F R2R is given by fx equal to mod x plus x, gx equal to mod x minus x. Okay, see that you have to find out f of gx and g of fx. F is R2R is given by fx equal to this and gx equal to this. So how you can solve this question? So to solve this question, we shall use the result. Mod x is greater than equal to x. We know this result. Okay, mod x is always greater than equal to x, whatever be on x. It's a very simple result. So if we use this result, we can solve this question quite easily. How to do that? See that we need to find out f of g and g of f. F of g, this can be written as f of gx. This is called composite function. I have made a video. Okay, I have prepared a video on composite function. Okay, link is given in description box. So go through that video. It comes under mapping. Okay, chapter mapping. So I have prepared 4 videos on mapping. Just go through those videos. So f of g means f of gx, which is equal to f of, what is my gx? My gx is mod x minus x. My gx is mod x minus x. Okay. Now let this one as y. Now mod x minus x equal to some y. So this becomes f of y. F of y. Now what is f of y? See that my fx is this. If fx is this, what will be fy? Fy will be mod of y plus y. If fx is this, what will be f of y? F of y will be mod y plus of y. Okay? Mod y plus of y. This is equal to. Now replace y. Now replace y by. Now replace y by mod x minus x. Here also replace y by mod x minus x. Okay? See that. So we think, okay, we let this one as y. This become f of y. And if my fx is this, my fx is this, so what will be my f of y? Replace x by y. So mod y plus y. Then put the value of y. This is my value of y, mod x minus x. Then again, y equal to mod x minus x. Okay, so how we can take this? Mod of mod x minus x. I'm showing you here. Now we know whatever be the value of x, mod x is greater than equal to x. That means this mod x minus x is a positive number because mod x is always greater than equal to x, whatever be your x. Mod x now always except greater or equal. That means this is a very basic property. That means this difference is a positive number. This difference is basically a positive number. And we know mod of any positive number is equal to that positive number. Mod of any positive number is equal to that positive number. So see that here whatever be the value of x, mod x minus x, this portion is positive. And since this portion is positive, mod of any positive number is equal to that positive number. There is a property, mod of any positive number is equal to that positive number. And this portion remain as it is. So if we add them, so my answer becomes this. So my answer of this question becomes 2 into mod x minus of 2x. So if you understand this question, if you understand this solution, find out g of fx. I'm giving you this homework. This can be written like this, g of fx. Then g of my fx is what? My fx is mod x plus x. Take this one as y. That means this becomes gy. So what is gy? Put x equal to y. Now replace y equal to this. It is totally similar to this question. Proceed yourself. See, there is a specific type of question. I shall make a prepare video on Chinese remainder theorem very soon. Okay. Then I shall give you the link of that video in this video. Okay, link of that video in this video. Okay, so I shall discuss Chinese remainder theorem in a separate class. Okay, and very soon I shall make this video. Okay, so at this moment we can leave this question, Chinese remainder theorem. And my last question, E, part 1. So what is E part 1? Oh, this is this is called phi of 2024. This type of phi function is called, we know, Euler phi function. Euler phi function. Okay. So we have to find out phi 2024. So at first we have to find out LCM 2024. This is called prime factorization. What is prime factorization of 2024? See that we are using prime factorization. Just check the calculation if we find any mistake. Yes. Then I think this calculation will be up to this. So 2024 can be written like 2 cube into 253 to the power of 1. See that how simple this question is. So I told you now, minor questions are very, very easy. For minor, you don't need to study any major book, or you don't need to solve any major questions. These are the basic questions that minor, that CU will ask you in minor paper. So these minor questions are very, very easy. It is totally not comparable with your major paper. Mathematics major paper and mathematics minor paper are totally not comparable because of their difficulty level. So this is called prime factorization of 2024. So if we get this prime factorization, there's a result phi n equal to n. Here my n is 2024 into 1 minus 1 by P1. But P1 is the prime number. This prime number is 2. Then 1 minus 1 by P2. This P2 is another prime number, which is my 253. See that. 1 minus 1 by P1. This is my P1. Actually, it is written as P1 to the power R1 into P2 to the power R2 into Pn to the power Rn. If my n is this, here my n is what? My n is this. P1 to the power R1, P2 to the power R2, Pn to the power Rn. It's a standard theory. You can find this theory in any standard book. So my 2024, this is my P1. My P1 is 2. My P2 is 253. My R1 is 3. My R2 is 1. Now calculate this. Maybe my calculation is okay. I can make any mistake. So just calculate this, you shall get the answer. So this is my answer of this question. Okay. So just pause this video and write down the solution. And my last question of this series is, you have to show that n square plus n plus 1 is a prime number or not. Or it is a prime number or not. But it is a natural number. So it's a very, very easy question. Either you can use trial and error method, or I am giving you a very, very shortcut technique. See that there is a number which is 41. Now we know 41 is a prime number. Okay, that means you can't write 41 as a product of two numbers. You can't write. It's a theory of prime number. So how we can do this? So let us take n equal to 41. Why you are taking 41? Because here we have 41. Because here we have 41. I'm giving you this shortcut technique. Since here we have 41, I'm taking n equal to 41. Therefore, my this expression become what? Put n equal to 41. 41 square plus 41 plus of 41. Now take 41 common. Which is 41 into 42. Okay. So just putting n equal to 41, n square plus of n plus 41. Actually, not 41. Let us take n equal to 41k. But k is an integer. See that, but k is an integer. K is an integer. Let us take n equal to 41 into k. But k is an integer. So then this is my 41k whole square plus of 41k plus of 41. This will give you 41 square into k square. I again repeat why I am putting 41, because here there is a 41 and this 41 is a prime number. That is why I have taken n equal to 41. Now take 41. This will be 41k square plus k plus of 1. Okay, done. So see that this product is a product of two numbers. Product of two numbers, and none of them are one. None of them are one. What is the definition of prime number? If n is a prime number, then n can be written as product of two numbers where one of them must be 1, either p equal to 1 or q equal to 1. Not both, either p equal to 1 or q equal to 1. If this is so, then n is a prime number. Okay. But here we have expressed this number as product of two numbers, and clearly none of them are 1. This is not 1. Again, this is not 1. Okay. That means what? That means this number is not a prime number. Not a prime number. Otherwise, you can say that this product is divisible by 41. This product is divisible by 41, and hence it is not a prime number. Okay. So that is your choice in which approach you are comfortable. Okay. So that is the answer of this question. Is that sure? Okay, that is another approach by using Diophantine equation. Okay, by using Diophantine equation, another solution can be given. Solution will be quite difficult for minor students. That is why I am giving this shortcut solution. Otherwise, the another approach is use Diophantine equation. Those are quite difficult technique. But it's an easy solution. You can go through this solution. Okay. So that is everything. That is all the solution from question number A to E. In my next part, I shall solve all the remaining questions and we'll start matrix. Okay. So meeting you in the next video. Till then, bye-bye.